Control System Toolbox provides control system tuning app, also known as CISO design tool, for compensator design using graphical and automated tuning methods. If you know your planned transfer function, sys, in the simple case 1 over s plus 1, you can launch Control System Tuning app by typing CISO tool of sys. The app opens up with two windows. In this window, you have two default plots that you can use for graphical tuning of your controller, root locus and body plot. In the second window, which is called Control and Estimation Tools Manager, you can configure your controller architecture, create additional loop openings, import new planned transfer functions and existing compensators, and discretize your compensator. Compensator Editor tab shows the structure of the compensator. Right now, it is just a gain of 1. In the Graphical Tuning tab, you can specify the plots that you want to use for graphical tuning. Currently, the two plots that are already up are specified here, root locus and open loop body. You can also add Nichols plot and remove any of the existing plots. In the Analysis Plots tab, you can specify plots to use for analysis. For example, the step response from reference to output. If you want to change the gain of your system, you can do that by adjusting the magnitude of the body plot or by moving closed-loop poles in the root locus editor. You can easily add poles and zeros to your compensator. In this case, the system needs an integrator to achieve zero steady-state error. Once the integrator is added, you can adjust the compensator gain to achieve nicely damped response. In the step response plot, you can check characteristics of the system. For example, you can see that the rise time is about 2.5 seconds. If you want to make the response faster and keep it nicely damped, you can add a lead compensator to the system. You can now interactively change the locations of pole and zero as well as the magnitude of the compensator. You can always go back to the Control and Estimation Tools Manager, and in the Compensator Editor, see the formula for your controller. Right now it has a gain, integrator, and a lead. You can edit parameters directly here. For example, you can place 0 at -1 and pole at -10. As the changes are made, notice how the tool automatically calculates the amount of maximum phase lead from the lead compensator and the corresponding frequency. Instead of typing 0 and pole locations, you could specify the amount of phase lead that you want and the frequency where you want it. The tool will automatically recalculate the values of 0 and pole accordingly. You can go back to the plots and see the resulting step response and the body and root locus. You can continue tuning interactively, again by adjusting the magnitude, or you can zoom in this region of the root locus and continue moving zeros and poles of the system. Once you have the design that you like, you can store it by pressing Store Design button. This creates a new node in the design history. You can name this design as you like, and you can store as many designs as you want here. You can continue tuning your compensator, but at any time you can select previously saved design and retrieve it. In addition to graphical tuning, Control System Tuning app provides automated tuning techniques, such as automated PID tuning, LQG synthesis, loop shaping, this one requires robust control toolbox, and optimization-based tuning, this one requires Simulink design optimization. At any time, you can export your current or saved designs to MATLAB Workspace, where it will be available as an LTI model for further analysis. This concludes the video.